welcome to Grease Thief Thursday. Today we'll be talking about grease sampling and analysis for robotic geared drives. I have the privilege of introducing Richard Janosky, who will be taking us through this PowerPoint today. So Richard Janosky has been with MRG Lab since 2003 and currently serves as a lab manager for MRG Labs. At MRG, he works on laboratory analysis, working with grease and oil. He also prepares data for customers and participates in research and development projects. He is ICML certified in LLA 1-2 and MLT 1. So, Richard, go ahead and take it away.
Thank you very much, Marissa. So, robotic gear drives and systems are being expanded across the manufacturing industry. They're used in many different manufacturing industries, whether it be food, pharmaceutical, auto manufacturing. So they're becoming extremely popular part, and it's an extremely important asset to maintain for function of a facility. Most industrial robots are 6-axis robots that include a grease lubricated gear drive in each joint or axis of the robot. A very important thing is the robot drive maintenance. So the grease inside of the joints requires periodic replacement. But one thing that we want to do on that is make sure that we're replacing it in the optimal frequency. So we don't want to replace grease that still has life left and can still be used. And then inversely, we don't want to use it too long and then we're causing damage to the joint or the axis. So that life of the grease is going to be dependent on the cycle times, the degree of movement, the load that it's carrying, any contamination possibly from the environment, and then the temperature and thermal cycling. So when we think about it in different facilities, each robots will have a different task. So it's going to be important to optimize that maintenance and lubrication frequency for each robot based on the things that we just mentioned, because if they're all doing different jobs, they're not going to need the same maintenance schedule, and we'll be able to kind of set them up appropriately to make sure that we're optimizing our robots' use. Manufacturer recommendations are typically time-based, and it's similar to a change out for oil. They want you every so often to put in the new grease, removing that old grease, and sometimes that can be it can be very costly to be putting in an expensive grease, and especially if that grease has remaining useful life in it, and we're able to show that through data through grease analysis. So first we'll talk about some of the regreasing operations for robot gear drives. So as we mentioned, it's important to optimize that relubrication of robots. Doing so can save money on grease and also on the time to perform the relubrication task. It's an important task, and it can be time consuming with the work to open up, make sure that do any movement required, anything like that the OEM might require when relubricating or regreasing the joints. The sample can also be used to determine which joints may require. So instead of having to re-grease all 6 joints, we would collect our grease samples, and the data might show us that just the one joint that's the most heavily loaded and is doing the most work is going to require the attention. And instead of doing all 6 joints, we're able to pick the one joint that needs the maintenance, perform that, and then allow it to continue saving time and grease in the maintenance operation. Here we just see some pictures of our maintenance technician that is putting grease back into this joint. All right, the grease thief for robot sampling. So there we see a picture of the grease thief into the relief port, And at the beginning there, you can see there's a little bit of that light tan colored grease that's starting to purge out from the robot. And this adaptation you see here is being used in a FANUC robot. They're extremely popular. There's also many other popular brands, and the grease thief can be used right there on that port used in help taking the sample. The grease sampling device allows for the grease to be captured at the motor drain we saw there in that previous picture. And then it also can be used to take a sample from an opening if that is also necessary. The grease thief maintains the purge function by not increasing or adding back pressure to the system. It allows that grease to continue to flow how it's intended. And then the design is also optimized for the analysis process. So we'll talk a little bit later in the presentation about on-site analysis, and it's ready to go for that. It's also nice and optimized for the analysis if it would need further or advanced analysis, and this would get sent to a laboratory where the grease thief is ready to go, being put into the analyzer to be extruded, and it helps streamline that process to make it faster for the customer. So routine sampling to monitor the health of grease. So ideally, when we're performing our grease analysis, we want it to be minimally invasive. We don't want to be opening up the system and being able to cause contamination from the environment or anything like that, or disturbing the system and kind of changing how it's working. Samples should be available ideally without disassembling the robot. This is to help save on time and effort. If it can be very, very hard, and it can also, like as we mentioned in the step before, opening it up and then we could introduce something that wasn't there before. And ideally, the sampling would be performed before the regularly scheduled maintenance of purging the grease or changing out the grease. And that's to be able to assess which joints actually do need that maintenance. If you take the sample when you perform the maintenance, that data that you're going to get back isn't necessarily reflective anymore of what's in the joint. So it's ideal to perform that analysis before performing the maintenance to understand what maintenance actually needs to get performed, and that can help save time and effort. And then the last thing on there, the method should leave the robot in a ready to run state. So we don't want to be putting in a lot of excess grease or anything like that that would put it in a condition that would be non-ideal for operation. We want to leave it similar to how we found it, ready to go for operation. So then we'll talk a little bit about the robot sampling kit. I have a picture on the next slide that you'll be able to see of the kit, but the kit allows, if we talked about threading in, sometimes robots may not have a port that you can thread directly into. The kit does have small sampling tubes that can be used to pool suction on the grease. It's often not possible on greases, but because of the low NLGI grade or consistency of robot greases, there are some that are able to be suctioned to be able to sample, but that still is not true for all greases. It's kind of a case-by-case basis. And as I mentioned there, the sealing syringe can be used with the gearbox in the right position, and that would allow you to take the supply side sample. And also the sampling method laid out in the kit with the instruction cards meets ASTM D7718, the standard practice for obtaining in-service samples of lubricating grease. So here on the right, you can see a picture of the kit. As we mentioned, robots often have 6 axes, so the kit comes with 6 sleeves to take a sample from each axis. They're supplied with a barcode label and identification for navigator so that the samples can be put in and data can be retrieved. That can also be done if you're screening on site to kind of monitor and enter the data in. And then that can help implement proactive improvements to extend the grease and component life. So if we can, with data, show that the grease still has effective life, it's got good consistency, it's got low wear, low contamination, and it still has antioxidants, we're able to show that we can keep that grease in the joint and it's going to be lubricating effectively as it's intended. So we'll run down sampling. So these are pulled off of the instruction cards that come with the kit, but if you would get a robot kit, they do have the instruction cards in there, and that takes you through and has some pictures as well for taking a sample. But the first thing we'll talk about is sampling for joints 1 through 3. And if you see the image there on the right, we're going to be counting from the largest joint on the bottom, and that'll be joint 1, and the smallest joint, joint 6, will be the last one out at the top. So the first 3 will be bigger than the last 3, so we're going to sample them possibly differently depending on the robot's size. So first thing we'll do is exercise or move the robot to mix and work the grease, making sure that if it was sitting, we're not going to take anything that might have settled, and then it would be non-representative of the body of lubricant. Then we will position the robot with the drain facing down if possible. If not, do our best to get it as close to that angle as possible, but there's sometimes obviously will be limitations on the robot based on where it might be set up or how it's being used. Then following safety, we'll shut off the power, lock out, tag out, and then remove the drain plug. The thread adapter of the grease thief is put into the gearbox drain if necessary. You can see that there on the end of the grease thief, there's a thread adapter to make sure that it's the right size for the grease thief to be able to fit in there. And then when fit snugly, you'll be able to pull the plunger handle and fill the grease thief. If that is not an option or doesn't work, grease can also be obtained, as we mentioned before, with the extension tube or syringe. And then there's also a spatula in the kit as well, that if you can't get suction, we'll be able to reach in to get some grease out of our joint. Then we're going to cap our sample, and then we will label it, and then that will be shipped to the laboratory for analysis, or it will go to manager's office or wherever the on-site testing gets performed. The testing would get performed on site, and then based on the criteria, maybe a handful of samples are going to the lab for advanced analysis. The other ones all pass the threshold and they're good to continue operation. And then there's no further handling necessary, and they're ready to analyze per ASTM D7918. So then next we have joints 4 through 6. So same thing, except for now we will have the Zerg fitting, and we'll position with the Zerg fitting facing down if possible again. We'll follow our same safety steps where we'll shut off the power, lock out, tag out so that nobody can be hurt, and then remove the Zerg fitting. And then the syringe you see there on the bottom right will be carefully threaded into the hole. The seal will be made by pushing and turning the syringe simultaneously into the threaded hole. And then once that's in there, the tip of the syringe will be able to be filled with grease. So if you see on the top part there, the syringe isn't completely full. You don't need a full 10 milliliters of grease, just a little bit there at the end. And then in the top picture, you can see that the syringe is completely pushed into the grease thief, and that technician's starting to push with their thumb on the plunger. And then in the bottom picture, we see that all the grease has been pushed out of the syringe, and the grease thief is full. And then now they're ready to put their cap on, and then put the label on, and then analyze or send out to the lab for further analysis. So now that we've got our sample, we'll talk about some of the on-site screening or analysis that we can do. So the key parameters can be quickly tested while retaining a majority of the sample for future testing if it's warranted. So on site, we find that using the FerriQ to measure ferrous wear concentration and the grease thief colorimeter to measure the change in color of the grease is able to monitor the conditions, and you can do so very quickly, under 5 minutes for a sample. And then if it's determined based on threshold levels, an offsite lab can do further advanced testing that would include FTIR and then anything else that might be deemed necessary by the customer. So we have the FerriQ there. You can see we've got the grease thief there in the picture. So once you take your sample, you would be able to drop that right in. The inductive coil would measure the ferrous content, giving the results in a ppm level. It's capable of measuring up to 200,000 ppm, has a 2% relative standard deviation, and then it measures small and large size particles, so the particle size will not influence the measurement of the instrument, and the results are ready instantaneously, popping up right on the screen. It is able to be set up with a Bluetooth or a USB cable to export CSV, or you can obviously hand record and it just runs on standard 12-volt DC power. So that would be used by customers on site to be able to do their own screening test for ferrous. And then along with the ferrous, we would do our colorimeter. So here we see the grease thief colorimeter. On here we see the silver block. This sets the path length. So there are different blocks that we can put in that vary the thickness of the grease that's being scanned. That helps for darker greases to be able to make sure that we're getting an accurate representation of the color of the grease. When the color darkens, it could be due to grease aging, wear, or oxidation. So monitoring a color change like this is very helpful, especially in a robot. Oftentimes it's a lighter yellow grease, and it's very nice to trend and track over time that change in color, and we're able to set those thresholds for our customers to screen. Same thing as the FerriQ. It's a very quick test, less than 30 seconds, and you have your data. And here we just see an example. So on the left image, we have a small minor change. So you can see that the delta E is very small. And then on the right, we have a sample that was oxidized, and there's been a large change in color. Our delta E is up 44. So that just is one way that the screening test can help, where if it's high wear, or if we have a change in color, we know that we're having one of those wear, oxidation, or contamination issues. So now we'll talk about a little case study that we have to share with everybody. So in this case study, we have a customer that has 110 robots in an automated manufacturing facility. They take samples before their scheduled maintenance to monitor the fleet of the robots. And then maintenance tasks are determined based on their data. So if a screening sample is all green, the robot joint will continue in operation. If it does not meet the threshold limits they have set, then that would trigger them to perform maintenance tasks on that joint to change out the grease and replenish. And they see an annual savings between $70,000 and $80,000 on those robots each year, and that's on the grease time for the services of the employees as well. We started with a custom test package with them to determine the screening limits. So at the beginning, they were sending all their samples to the laboratory, and we were able to help them work through and set up the limits for their ferrous and color screening, and then that helped them be able to understand when they might need to catch a sample, send it to the laboratory, and then there are still sometimes we get a sample where we do the full analysis and we're able to show with data that the grease is still um, effective and good to go, or that the grease does need replenished. But they're able to use that data to make the decision versus just trying to go off of a gut feeling or anything like that. Then I have some the data just to show. So this is the ferrous data. The ppm scale on the left there is in a log scale, just so it doesn't look like it goes crazy on you. But we can kind of see that out of this recent set that they did, that all of them but 3 of the samples were green, so they're going to be good to continue in operation. And then these 3 joints have been flagged for maintenance work, and we can kind of see here some high ferrous. And then those 3 robots too traditionally are doing a little bit heavier work than the other robots, so that also makes sense that they've seen that trend over time. And then here we have our color data. So we see the same 3 joints are guilty as the same 3 joints that had high ferrous levels. So kind of we see that correlation between wear level going up and then there being a color change. And we talked about that when we talked about the colorimeter for screening. But this just shows again that a majority of their samples are good. There's just a few that they're able to catch through their screening analysis, and they're able to perform the maintenance just on the joints that need it. So we saw that 3 of the 22 samples needed further analysis at the laboratory to determine, issues, if there were any issues, and then performing the maintenance on them. The other joints were good to continue in operation, and this saves the customer time and money. They're able to get the answers that they need, and then they're performing the maintenance tasks on the joints that need it instead of just doing it on every single joint. Are there any questions?
Nice job. Can you hear me okay?
I can hear you lightly, Rich.
Okay, is that any better?
Yes, it is.
Okay. Hey, nice job. And can you talk a little bit about, you gave a few examples there. I think you're protecting the innocent by not saying, who they are specifically. But can you talk a little bit about some of the applications? What kind of environments are you seeing folks do this analysis? Where are these robots deployed and what are they doing?
Yep. A big one that we're seeing is in the automotive industry. So there's a lot of robots being used for the automation or to help with the automation of vehicle assembly. We definitely see some automation in some different steel mills in our area that have some automated stuff. And then I think local to our area too, we have a lot in food production and pharmaceutical production. I think probably be like the big ones that jump out to me as far as users that have robots, and it's not just 1 or 2, it's a lot. So it has a real big impact when you're able to save some money on each robot, and then you've got hundreds or possibly thousands of robots across the facility. It's a very, very large savings that can be had.
Yeah, that's great. And you're right. In our region here, we do have a lot of food processing. In fact, my daughter Mary is working in an egg processing facility, and they're certainly using robots for some of the packaging sides of things, stacking and boxing and packaging and so forth. Can you also talk a little bit about the connection to our area here in York, Pennsylvania, and how we first started testing robots in our our partner in that?
Yes. So we started working with a local company that's a machining manufacturer called Weldon Solutions. And they manufacture services like CNC grinders and other integrated automated solutions for machine shops. And we worked with them. They were very gracious, allowed us to come on site. That's where some of the pictures you saw today in the presentation, and we were able to go there. They showed us kind of what they were required to do as far as, for the OEM when they did their regreasing or relubrication tasks, and kind of helped us understand the level of effort that was really involved. And then they were very, very helpful also in allowing us to kind of come in, take samples. We were able to develop the robot kit when we were working there. And I think that that's been very helpful for us. They're located right down the road from us, so it was very convenient for us to have that right there at our fingertips.
Yeah. So as a laboratory that's looking at taking on this technology and helping folks, not only do you have the people that are using the robots in their facilities, but you also have the service providers, and Weldon is an example of that. Another one is the grease manufacturers, right? We've done some work there.
Yes, we have, and I think it's one of the things we learned that basically, there's a lot of positions where robots are now being used. I think even just a couple years ago, it might have been priced out, but I think now the technology has quickly improved, as technology always does, and it's becoming much more affordable, where I think it's going to be a big part of the industry sector going forward.
Yeah, definitely an area of growth. I just saw today a posting from Fanuc, who you mentioned, and I think they manufactured their 700,000th robot, and so it's a lot of opportunities. It's growing fast, and as you see that from a laboratory perspective, the opportunities are getting broader all the time, and it's really global. So we mentioned Fanuc. What about some other manufacturers?
I know that we've done some work on some ABB robots as well. And, oh man, I feel like I'm blanking on the other one.
Well, now some of the ABBs I've seen are oil lubricated. So I think there's examples of both, but there's a lot of oil lubricated joints there. Kawasaki would be another. Nachi, I think, is one. But a few different, Motoman, another from Asia. And it seems like a lot of the Asian-built robots and manufactured robots are grease lubricated in that regard.
Yes.
So on the color, you talked about the color. What is the color really triggering? You gave us that example of where colors was changing when the ferrous level with the FurrowQ was increasing. When does color change when it's not the wear level?
Yes, so if our wear levels are nice and low and they come back green, but our color would still be high, there's the possibility of grease mixing, and the wrong grease has been introduced, and the grease is a different color. So that would cause a change in the delta E response of the grease compared to the baseline. It could be accumulation, we mentioned, of contamination. So if it's in an environment that is dusty or dirty, and it's opened up for a sample, or it's opened up for maintenance, and we're not being careful when that's opened, we could introduce any kind of number of factors from the environment that would cause that color change. And then the last one is oxidation. So if our sample started to oxidize, we would begin to see the grease darken. And that was the example. I'll go back to that slide. That was the example that we had actually of that sample, was that it was oxidation. So you can see there that on the left, that would be a typical change of the grease while it's in service, just minimal, a little bit of darkening. That would be the darkening due to aging. And then on the right, we see that it really did get dark brown, and that is from the oxidation of the grease. So it's lost its antioxidant additives, or they've been depleted. Not so much that it lost it, but they've been depleted, and now the grease is starting to oxidize inside that joint, and it gets much, much darker very quickly.
Yeah, I think this one is great, Richard, because it's the visual aspect of it just tells that story. And I know you mentioned Weldon Solutions here in York, and we first started thinking about robots. I recall a guy named Ben Kornbauer. We got together and followed him on some service calls, going out to see people's robots and so forth. And we tagged along, took a bunch of samples. And at the end of the day said, hey, thanks for letting us do that. I'm going to head back to the lab and see what we have here. And he said, oh, you'll have problems on number 3, number 4, and number 8. I was like, well, how do you know that? Were you doing other testing when I was pulling the grease samples? He said, no, I can just tell by looking at the grease sometimes. So, he kind of gave us that idea that there is something from a visual standpoint, or at least a observable, visible light difference in the grease that tells us that there's some issues there. And we can't all have the experience of a technician that's looking at robot greases every day and, can kind of connect that to the conditions that he sees. But when you can use something like the Grease Thief Calorimeter to screen out, to look at the numerical values, to trend them and to create some criteria, or you use the FurrowQ that can look at the ferrous content and really, see what's there and use some criteria and do that right on site. That's so helpful. And Bobby just asked a question while I was talking about that for the colorimeter, and he asked about, what about on moly greases and some others. There are some limitations with the color. Certainly when the grease starts black, it doesn't really have anywhere to go from there. But you do see, Bobby, with the Grease Thief colorimeter, the ability to use different spacers and to really thin that grease down to a very narrow path length. And we have it down to capability down to 0.005 of an inch for the path length. And that really brightens up the response of the colorimeter to even some of the darker greases. So it really just depends on, what that content is. Certainly for robots, Richard, we've seen colorimetry be very effective because of how light colored the grease is when it starts, right?
Yeah, oftentimes robots we find are the easiest or the best to set up a trending ability on color because of the light color and as they get darker, so they have a much larger color range that's acceptable. Whereas like Bobby, asking about darker greases, sometimes you might have a dark blue grease that a change of 6 is huge just because of how dark the grease is. So it's, always adapting. So they make it much easier to set limits and say, hey, up to 30 is acceptable. We've noticed that above 30, we're getting into a range that likely we have some kind of contamination, wear, or some issue starting to happen at this point versus up to that point. It's kind of typical.
Yeah. And we are seeing, that's another thing we've been getting involved in, Richard, is the testing of different kinds of greases. Because if you turn back the clock when, the robots just started in the early days of their growth, pretty much one grease was being used. And then there was a little bit of a period of an alternate grease being used. But now we're seeing more different kinds of greases. I think some different grease manufacturers are coming onto the scene with products that they say can be used. And certainly it creates a potential for mixing. Color can help with that. It creates, potential issues of where that grease doesn't hold up. It gets dark or what have you. So color can be really important in that as well.
Yep.
Great. Well, we had a couple good questions there we were able to address. And Richard, thank you for diving into this topic and letting us see that. What can folks do? What are the options? Take it from the person or the manufacturer that has a handful of robots on their facility. What kind of steps could they take, to somebody who has a whole huge fleet, to the laboratory that might be listening in and saying, how can I get my lab up to speed on being part of the robot grease analysis opportunity?
Yeah. You could reach out to myself or Marissa. Be happy to kind of discuss the kits. I know sometimes, it's important to understand each person's specific situation, what robot or what kind of work they're doing. We'd be happy to run through the kits, talking to laboratory or an end user and making sure that they feel comfortable in what would come in the kit, the instruction card, and then kind of what they'd be doing with their robot to take the sample. And then from there, as I mentioned earlier in our case study, we've had experience with a couple customers. That's not our only customer with robots we've done this with, but being able to help understand the first couple sample sets, setting those limits, and then the customer's able to perform the on-site analysis screening-wise, and you're able to make those decisions in good faith, knowing that the history of the data is there from the laboratory, and they're making that in confidence versus just, like you mentioned, just saying, well, it doesn't look right, so I just know there's something wrong. And it's, it's nice to be able to quantify and put a number on something to say, all right, we're good, or we might need to take action. Let's find out a little bit more.
Yeah, so it starts with the kits, and of course, robot grease sampling kit is one of the options we have with the Grease Thief kits. And then you've got the mini lab option, right? If you've got, I think the kits are right for someone who has just a handful of robots. Get the kit, sample it, send it into the laboratory. But you got a big enough fleet, you got to think about mini lab, right?
Yeah, definitely. If you have like we mentioned, our customer, they've got in the area, it's not the whole facility, but just in his area, it's 110 robots that he's working with, and he does his screening there. And then, there's definitely times where he, asks to set up a call and wants to discuss something that he thought he saw or anything like that. So it's having that relationship with your customer, or if you're the customer, having that relationship with your laboratory, making sure that, you can call and ask a question and lean on them, and they're going to support you, in that, giving you the right feedback to make sure that you're taking the correct action to protect your asset.
Plus the additional testing that the lab will have capability-wise to go beyond what's in the mini lab, right?
Yes, correct. Yeah, it's definitely is helpful. And if you think you've got something and you want to find out, it's nice to be able to just send off one sample for that advanced testing versus, 100 robots times 6 joints. You don't want to send off 600 samples, but you want to send that one sample that is the problem, and you're able to kind of find out, what might have done this.
Yeah. And then back at the lab side, the labs can not only look at the color through the Grease Thief colorimetry and the ferrous with the FerriCube, but also the Grease Thief analyzer. And I think when we're thinking about robots, we've got that consistency issue, right? The grease can be hardening or softening, especially when they're transitioning to other products. And then, the whole idea about particle counting that's there in the Grease Thief analyzer.
Yeah, that's definitely nice, especially in robots, that joint is intended to be closed up and doing that work with that certain viscosity. So if your grease is changing drastically, and if this is a robot that is picking up, a big heavy car frame or an entire large pallet of something, that can, things can happen very quickly when you've got that large load in the application.
Yeah.
And I know too, you mentioned consistency. The other one that is helpful too for especially robots is the ruler test for antioxidants. And we find that that's been extremely helpful in being able to prove that sometimes we have a grease that is very old, and for example, like it's not quite as dark as that oxidized sample, but we're able to test it and we're able to prove that this grease is just dark based on color. It's got antioxidants remaining, it's got low wear, it's got great consistency, and this grease will perform as intended in service. Its color is just different. So that's also an example of sometimes the color changing might not be a bad thing. It's what happens over time, but the grease is being taken care of through maintenance practices, and you can continue to use it.
Yeah, and certainly if a customer, an owner of robots, can avoid having to shut down to do a grease change out, that keeps that robot in business, and that's where the return on investment is. Keeping it reliable, minimizing the downtime, getting much of the life out of the grease as you can, and only changing it out when it has to. And unfortunately, in the past, it was very much like operating hours, X number of operating hours, change out the grease, with no mind towards what's the temperature of operating environment, how quickly does the grease actually degrade, how hard is the grease being worked, how heavy a component is being picked up, and are all the joints moving or just one or two? So there's a lot to consider there and a lot of benefits, and that went into that significant cost savings that you gave us in that case study.
Yep.
Yeah. So I think, was Marissa going to share with folks that video? So maybe I can back off now and kind of turn it back to you guys.
I'd be happy to share the video. So looking, you should see it on your screen now. So when you're looking at this video, just keep in mind a few things. Is when we talk about harmonic drive, we're actually talking about a lubricating joint. And then when we say Hall effect sensor, it's just going to be a sensor in general. And then here we talk about how the grease must be purged from the robot. But as we learned in this presentation, you can just use a syringe or a grease thief to get the grease out. So please enjoy this presentation, this nice video.
Over the next few minutes, we invite you to learn about an exciting opportunity that will improve lubrication of your industrial robots and change the way you monitor the health of your grease-lubricated machinery. The fact is, robots are changing the way we do business and increase productivity. But we must properly care for robots,
I don't think we have audio
just
here.
as we would our human workforce.
Richard, I think it's just you that doesn't have audio. We have, I've heard some other people that they get audio. Does it also have audio?
Huh. Okay, try it.
The care starts with a maintenance strategy that allows for monitoring of the lubricant inside the robot joints and the condition of the robot itself. MRG has developed the Grease Thief, a technology solution for obtaining trendable grease samples and analysis with as little as 1 gram of grease. Samples that are analyzed with the Grease Thief provide broad insight into component wear conditions, grease breakdown and mixing, contamination, and loss of protective antioxidants. Evaluating the true condition of robotic joints starts with the proper sampling procedure. In order to fill the Grease Thief with a trendable, reliable sample, a specific amount of grease must be purged from the robot. As you can see, at this sampling location, we use an adapter and a Grease Thief body with a plastic bag zip-tied to the end to purge the proper number of pumps of grease from this joint. We remove the clear plastic body and bag and insert the Grease Thief into the adapter in the purge hole. We add only about 2 more pumps of grease to fill the sampler. The Grease Thief sampler is then removed from the purge hole and capped and sent to the laboratory for analysis, where it can be evaluated for wear, consistency, contamination, and oxidation. How can significant testing be done on 1 gram of grease? The answer lies in the efficient Grease Thief analyzer design and the patented technology that lies behind the Grease Thief extrusion die, an innovative device that both evaluates a grease's change in consistency and prepares a thin film of grease for analysis. This streamlined analysis method drives overall sample processing costs down. And enables the most cost-effective analysis options. The grease thief removes the typical time-consuming handling steps in the lab. Without any preparation, the grease thief can be directly inserted into a Hall effect sensor to measure total ferrous content of the sample. Then, an extrusion die is placed on the end of the grease thief and loaded into the analyzer for preheating to the analysis temperature. Under variable pressure and force conditions, grease is extruded onto a plastic substrate to measure its consistency, while the sample is optimized for further analysis. In the final phase of the extrusion, the grease is squeezed through a 40,000th inch wide slot to create a uniform thin film that is deposited onto the specially designed substrate. The substrate has peel-away sections, each containing 0.25 grams of grease, which can be conveniently moved to other testing stations around the laboratory. Up to 6 other laboratory tests can be done with a single substrate, including FTIR, ruler, metal spectroscopy, analytical ferrography, grease colorimetry, and rheometry. Incredibly, these provide a full analysis test slate, examining grease in all 4 critical test areas, including wear, consistency, contamination, and oxidation. In fact, all of these consumables are disposable, which removes the risk of cross-contamination between tests and eliminates the time-consuming tasks of cleaning and preparing grease samples the old-fashioned way. This graph shows the kind of information available just by running a simple wear test on this set of 30 samples from FANUC Model 2000 harmonic drives. 3 outliers in this group are immediately apparent and provide a clear differentiation that will allow a prioritized strategy of inspection and maintenance that will minimize downtime and reduce the chance of unexpected failures. Care and maintenance for your robots can be a daunting task, and MRG Lab's Grease Thief Sampling and Analysis System can provide meaningful, insightful data and knowledge to increase the life of your robot and optimize the use and replacement of grease in the critical harmonic drives. Until now, conventional wisdom has been that laboratories could not provide meaningful grease analysis. After all, grease can be tricky stuff. But with Grease Thief, questionable sampling methods and high-cost grease analysis are a thing of the past. Capitalize today on this tremendous opportunity to eliminate unnecessary grease consumption, optimize the health of the grease-lubricated harmonic drives, and pinpoint latent wear issues in your critical manufacturing systems. Problems may be hiding inside your robots. Take the next step to uncover these issues and ensure reliable, low-cost operation of these critical assets.
Thank you very much, Marissa, for playing that video. We'll wait a minute just to see if there's any other questions that come in. But before we're done, just wanted to let everybody know, next Grease Thief Thursday topics that we have coming up, we'll soon be talking about analytical ferrography again, and we will have Ray Dally joining us again from Trico Corporation. And this time we'll focus on some case studies. So we will make sure that we share the previous video for anybody to watch to make sure that they get some of the background information on analytical ferrography so that it makes sense when we jump right in to looking at slides and talking about case studies for that second analytical ferrography one. And then we'll also be doing Grease Thief Thursday on proper grease storage and handling. So often an overlooked but in very important task at facilities all around the world. And so those are our next 2 Grease Thief Thursday topics coming up. All right. I don't see any questions, so thank you guys very much, and look forward to having you join us the third Thursday of next month in August. So that'll be August 19th at 1 p.m. Eastern Standard Time. So thank you very much. Hope everybody has a great rest of your day, and look forward to seeing you next time.